example 4 and 2.3, last example here, and it's dealing with a real-world application of a radical equation, which is really free fall. We talk about this a lot in physics, but I don't want to get too much about that. Part of the hassle of dealing with these types of questions in math is that you have to know what the variables stand for, and they typically tell you in the question. So they said that v is the final velocity or velocity after it's dropped a distance of d in feet with an initial velocity. We call that v naught for the subscript 0. And then finally, the constant acceleration a in feet per second squared. So we are working in metric, but the good news is that physics works in metric. It's just some of the numbers end up being a little different because we're using different units. So what I'm going to do here is I'm going to rewrite the equation just so I can manipulate it in the bottom, and I get that v is equal to the square root of v naught squared plus 2AD. And then from the information given to us in the question, they tell us that the design specifies that the speed of the cars be 120 at the bottom, so that's just going to be v. The initial velocity at the top of the drop, that's v naught, was only 10. And the acceleration due to gravity is 32, and they're asking us for the vertical drop required to meet those basic needs, right? Somebody has said that I want to make sure people are going 120 at the bottom of this roller coaster. How tall do we need to make it? That's really what this question is asking. And the way that we solve this, I think, is by approaching this and identifying the value of the variables we know and the variable that we're looking to solve, and then substitute everything in. So I'm really looking to solve 120 is equal to the square root of 10 squared plus 2 times 32 times d. Now, I think it's a little bit beneficial to simplify this a little bit, and I'm going to say then that 120 is equal to the square root of 100 plus 64d. Now, this is certainly a radical equation. One of the things that's a little bit beneficial here is that if you look at the inside of that radicand, we could do our pretty common technique and identify that 100 plus 64d must be greater than or equal to 0. So 64d must be greater than or equal to negative 100, sorry. And I get that d must be greater than or equal to negative 100 over 64, which is, about 1.5, give or take, or negative 1.5. But d is the vertical drop. Can I have a negative vertical drop? That's not a drop anymore, that's a climb. So really what's happening in this question is that whatever solution we get, we really want to make sure that d is greater than or equal to 0. And in all honesty, it does have to be greater than 0. And that's from the context of the problem, which makes that a little bit tricky. Right? It is not a vertical drop unless d is a positive number. And then the roller coaster is climbing and gravity is not going to accelerate at that point. One of the problems that students do have with questions like this is they tend to showcase some of the physics that we learned in high school. So hopefully you have taken physics 20 or at least remember some of the physics in science 10 because some of those little things, I mean, not in a big way, but some little things like understanding that acceleration only speeds us up if we're falling, not if we're rising. And that's a more in-depth conversation that, a physics class would get into, which if you want to talk about it, email me and we'll have a good conversation about that. What we're going to do then is we're going to solve this equation in black, and I'm going to do that, and I'll write it out by squaring both sides. Now, when I square the right-hand side, we get kind of the ideal situation, which is that the radical symbol disappears. And that's such a maybe bad way of saying it. It's not that it disappears. It's by squaring both sides, we've undone that operation, right? We did the inverse of that. Okay, on the other side, 120 squared is a pretty big number. It is 14,400. But in order to solve this, I have to subtract 100 from both sides. I get 14,300 is equal to 64d. I then divide by 64, and what I get, sorry, just typing that in here, is that 223.4375 is equal to d. So the vertical drop to the nearest foot is 223 feet. If we wanted to do this in metric units, we would have to convert everything into meters or meters per second squared, or meters per second, I suppose, for the velocities. One of the nice things about doing questions like this in Imperial really shows that the math doesn't change. This is a science teacher in me. I am firmly in belief that the metric system is better than the Imperial system, but ultimately the math and the physics that we've learned throughout the millennia still work. So it really doesn't matter. You have to be comfortable with taking the paragraph and identifying what I did right here, which is what variables are given and what variable is the unknown. All right, so that's the last example. So I'm just going to put up the kind of typical assignment there. Please do make sure you're checking Google Classroom for any sort of modification and keep chipping away at it.